Okay, we are going live.
Yeah, am I audible now?
Yes, you are.
Okay, that's good. So, hello everyone. My name is Deepak, and I have been working in IT industry for about 15 plus years now. So I have been working in lot many different technologies, and big IP network is one of them. So here is my brief introduction. Um, so I think we can start with our session today. It is dedicated to big IP LTM, as you all may be aware of. So now, so agenda of today's session is to make you aware of all the different components which are involved in big IP network solution. So, so what I mean to say that there are a lot of there are different kind of services in the software modules which are being offered by big IP networks. So big IP network is a company which is providing all these beautiful softwares to allow you to optimize your application delivery center. So here big IP is introducing a lot of software modules, and the session for today, that is big IP LTM, that's one of the modules. So the agenda of today is of course we'll be going we'll be doing a deep dive into big IP LTM, but today I'll be trying to set a platform for you to have a basic understanding of the entire landscape which runs hand to hand. Um, so what I mean to say, that there are other modules of big IP networks which work hand to hand. So if you are working in a corporate environment, you're working as an IT administrator or an architecture, so you must have a basic understanding of where all these components fit and how they all work together. So so let's start with the session. So in this slide, I've mentioned a couple of a couple of more frequently used big IP softwares. So the first one and foremost is big IP local traffic manager. So that's where we are dedicating all our session today. So big IP local traffic manager, as the name suggests, that it is there to manage all your traffic related components. So when I say traffic related components, so you can assume a box which receives all the traffic and which has a capability to see that traffic, and you can engineer that traffic. You can customize that traffic according to your need. So in a normal run, usually people know big IP LTM as a load balancer, but let me tell you that load balancer is one of the component of the big IP LTM solution. There are a lot many other features apart from the load balancing which big IP LTM offers. So we will surely go in deep looking into all those options, why it is not just a quote unquote a load balancer only. There are a lot many other things. So we'll certainly go deep into the details. So second module is your big IP DNS, which we usually refer as a GTM, global traffic manager as well. So now F5 has been selling these products with the name big IP DNS. Earlier, they used to be called GTM. So here, as the name suggests of this product as well, that it's a DNS solution. So there, I mean, this GTM product provides you all the feasibility you can expect out from a normal DNS. So you can create all kind of records there. Like you can create an A name, you can create a C name, you can create a TXT record, SPF record, etc. So there are a lot many. I mean, apart from these normal things, what a normal DNS does, there are other things as well in GTM, which actually makes it special. So we will again have a quick review of what GTM is being used for, why it is not just a DNS, why, I mean, what all features you get from this GTM box. We'll take a quick look on that part as well. So any question as of now? Any questions you guys have? All right.
No.
So yeah, that's fine. So let me move to another software module which BigIP offers. That's Application Security Manager. So again, as the name suggests, it is something related to security for sure. So here in this module, what you get, that all your, I mean, if you understand it properly, all your LTM and GTM requirements is specific to the application. So we need a certain kind of module which focuses into the security area of the application layer. So this is the module which offers you the application layer security. So if there are any brute attacks, or if there are any SQL injections, or if there are something wrong with the HTTP headers, it detects them. It is capable of taking actions on that as well. So the next one is Access Policy Manager. Again, the name says everything. It is something related to access policies. So in a normal infrastructure, in a normal scenario, a corporate may be exposing their applications to the public, to the internet. And if you classify the kind of those information into two categories. So first category may be the application, which is openly available to everyone. Like if you want to browse bbc.co.uk, of course you can go there. It is open to everyone. You don't need to log in, you don't need to do anything, you don't need to provide your authentication password, MFA, etc. You just purely go in there and surf it. So another class of applications can be which are available to the public internet, but these are dedicated to certain set of users. So for an example, we can take an example of Citrix. So the organization where you will be working, you must be, I mean, you must be having some remote connection solution, so that when you're at home, you can connect to your corporate network and do your office work. But this application is, of course, published to the internet, but the access to this application is specific to a certain set of authorized users. So here, your APM, Access Policy Manager, of course, that comes into the picture. So it allows you to publish your application to the public cloud, and it offers you all possible mechanisms to check the authenticity of the user who is connecting to it. So like you must be using some applications where you need to provide your MFA, I mean, you get an SMS on your mobile, you put in that OTP and then log in, etc. So these are the kind of feature which is offered by APM. So moving next, that's our BigIP advanced firewall manager. So these are advanced firewall, like there are other vendors as well. So these are quote unquote network firewall. So whatever you can get from a network firewall, this module can help you achieve that as well. So you know, like there are other firewalls in the market as well, like Palo Alto, you must have heard about, or Fortinet, Cisco as well. So this is kind of the same thing. And another one product is Secure Web Gateway. So this is a kind of a, not kind of, it is indeed a, you know, forward proxy solution. So forward proxy means like you must be having blue code proxy in your environment or WebSense or other things which is there in between working as a proxy and allowing user to access the internet. So yeah, so this product is specific to the, you know, your forward proxy requirements. So any questions as of now? Okay, so I can move on the slide. Right, so now we are quickly jumping to have an overview of the BigIP product line. So as of now, BigIP is offering lot many platforms. I've mentioned some of them which are commonly being used. So the first line of their products is, you know, the normal hardware platforms. So these are the basic platforms. You can choose one of these platforms as per your requirements. So requirement is specific to the throughput and the number of modules you want to run on the top of it, and how much traffic is going through those platforms. So yeah, so the other line of product is BigIP I-Series hardware platform. It is relevantly new. It's been quite some time, but yeah. But it is relevantly new. It is focused on programmability, because today we are all moving towards the cloud environment. We need a flexibility and the programmability, and of course, it offers. I mean, it offers the greater size of memory. Also, the SSL, there's a separate module for heavy SSL offloading as well. So the other one is VIPRON Chassis. Right. So VIPRON Chassis is a kind of chassis, as the name suggests. You can install the blades on it, and you can then run your modules. Could be any of these modules which we discussed in our last slide. You can run it on top of it, and deliver the services. These are very good options just in case you are hosting a kind of a private cloud, like you are dedicating your data center for, you know, to host services for the different clients. You can create a virtual instances on these VIPRON chassis. You can just increase the throughput, increase the hardware with the newer blades on it, and then you can create modules. You can create a separate instances of BigIP for separate clients. So these are very good options if you are running a private cloud, or if you're running a larger environment and you want a very good scalability that you don't know about the future, you are expecting to grow in future, then you need a hardware which is scalable. So the next one is virtual editions. So these are, as the name suggests, these are the virtual editions. If you have any hypervisor or ESXi or VMware, you can run the image of this BigIP software on top of it. You can create a virtual machine, and then you can literally achieve anything what you can achieve from the hardware. So these VM editions are priced by throughput. So when you're going to procure a VM, you will have to explain what kind of throughput you're looking for, and then they can dedicate a price for that, and then they can offer you the license for that. Right. So it starts with the 10 Mbps. That's a lab edition only, because you don't run heavy things on the lab environment. This suffice for a lab environment, and it goes up to 10 Gbps. So it's just all license based. You just go explain your requirement to your BigIP sales representative, and they can offer you the best. They can suggest you the best VM, and they can price it accordingly. So now, yep.
Sorry.
Yeah.
Good morning, everyone. My name is Fawaz. I have one question, please. My English is not good. I'm not really understand the difference in BigIP hardware platform and BigIP iSeries hardware platform.
I'm sorry, I didn't catch you. Which one you're not able to understand? Sorry.
I'm not really understand the difference in BigIP hardware platform and BigIP iSeries hardware platform.
Right. So iSeries is basically meant for the programmability. If you're running in a cloud environment and you want to integrate it with your cloud environment where you are running SDNs, etc., then these are the recommended one. So as a hardware wise, it is offering higher memory and a higher number of connections its SSL module can handle. Right. So does that explain that? Does that explain what iSeries is for? Although you have a SSL module, SSL hardware module in all the hardwares, but it offers you the higher side. It's around 45,000. I think, yeah, 45,000 sessions per second that can offer you up to that speed.
Okay, what I understand is that iSeries is used for cloud, so is silver line solutions. iSeries cloud solution.
Yeah, I mean, these are best suited for cloud. It does not really mean that you cannot run it in your normal environment. So I mean, the only thing is that in order to extend the programmability, you need a hardware with a higher memory.
Okay.
So it does not really mean that you cannot run it. Yeah, if you get a chance to go to some BigIP representative, they can still offer you for your small to medium kind of infrastructure. They can still offer you, but since they are bigger in size in terms of memory, in terms of their capability to handle the complex SSL offloading, you can use it with your cloud environment where you can run the SDN and use the programmability of the SDN.
Thank you.
Okay. All right. So now that we are done with having a little review on the hardware side or the kind of platform, I'm just including that VM side on as well. So here is what is commonly being used as well, which is known as VCMP. It's virtual clustered multiprocessing. So what you can do with this, it is kind of hypervisor, like as you're running ESXi, you can create multiple VMs on top of it. It's kind of the similar solution where you can have one hardware, and on top of it, you can create the virtual instances, and then you can run one or more modules on top of it, right? So this is what I was mentioning, that as I mentioned in the last slide, these are the VIPRON chassis, which is good in scalability. If you are running a kind of an environment where you are offering services to multiple clients, and you want to create a separate kind of instance for client number one and another separate kind of instance for client number two, you can run a single hardware box, and then you can create it as a VCMP host. On that host, you can create multiple instances. You can dedicate it, of course, to any client, or if you want to use it to single client, multiple instances for a single client, you can of course use that as well. It's just the way how you connect it to the network, you can use it. So just there are many, I mean, there are other hardware as well apart from VIPRON, which support this functionality. So VIPRON, I'm only focusing because it has a feature of scalability, right? But there are other hardwares as well which supports VCMP. So not necessarily that you have to have a VIPRON to run this. You can use so you can go to BigIP F5 website, and you can search what all models, what all hardware support this functionality. Okay. Right. So this is something really interesting. I would rather emphasize on this slide, because the life cycle of any F5 platform, be it its virtual edition or be it any hardware, it is slightly different than what the life cycles of other vendors' product are. So how it is different, and this is a very good piece of information, because sometimes if you don't notice how the life cycle of a F5 platform works, you may somehow get caught off guard. Right. So let's just have a brief discussion. What is the life cycle, and why this piece of information is must to have. Right. So as BigIP releases any hardware, it is available in the market. You can purchase it. You can avail all the features. There will be regular new, minor, or major software releases coming in, and F5 will also be providing you support on these hardwares. If there are any maintenance releases, they would still be available to you. I mean, as they launch their product in the market. So all these things are available to you. So the next stage comes when they declare end of sale. So that depends on product to product and their assessment, how long they want their product to be in the market. They just declare the end of sale date. So the end of sale, when it reaches, they would not be selling any new hardware for that platform, as the name suggests. So the next phase comes. It is around right after 2 years when the end of sale is hit. So after 2 years, it gets into the end of new software support. So this piece is very important to know. So the end of new software support, what does that mean? That it means that when a product enters into this stage, the F5 BigIP, they will not be releasing any new major or minor software for these platforms, right? So after this date, you wouldn't, F5 would not be introducing any new major or minor releases of software. So this information is best to have. And so there are two things to focus. So when I say major or minor updates, I'm sorry, a major or minor softwares updates. So these are like, if you are presently working on version 15, so that's being the major version. And if F5 is releasing a newer version, so a newer minor update as 15.1, 15.2, 15.3, and so on. So these are the major or minor software releases. And the other part is maintenance releases. So major or minor software releases is different than your maintenance releases. So maintenance releases means if the software which is running on the BigIP platform is experiencing any bug, or if there are any new vulnerability experienced or detected, F5 will still work to create a patch, a security patch or hotfix for those particular gray areas. So when I say that it enters into end of new software support, they will from this point stop producing any new major or minor software updates. However, they can still be providing you the maintenance releases for those softwares, right? And the next phase, which is right after 1 year, when it hits, that's known as end of software development. So end of software development means that after this date, BigIP will no longer be producing any maintenance releases as well, right? So your major and minor software releases stopped on the milestone where it hits end of new software support, and your your maintenance releases will also be stopped for those softwares when you hit end of software development, right? So after that, BigIP offers you an extension support period of around 4 years. So in this duration, F5 will continue to support the software, whatever was capped on end of new software support date. They can continue to support that. you are still eligible to get an RMA just in case something goes wrong with the hardware. You are still eligible to get an RMA. But during this 4 years of tenure, you would not be getting any new major or minor software releases. You will not be getting any bug fixes, any security patches, etc., which in my opinion is a threat. So so while managing the life cycle of any big IP product, you should not consider the end of technical support or end of RMA date. You should only keep in mind the date when it goes end of new software support, right? So I mean, this is my understanding. I mean, I'm telling you this understanding from my practical experience, that if you are making your plan that my hardware is going end of RMA or end of technical support date after these many years, you may be planning it wrongly, because just in case you land into end of software development stage and you're still running your product, you are exposed to the risk that if any vulnerability, if any security risk is exposed, it is exposed to any security risk, there is no support, there is no bug fixes, there is no security patches available, right? So I thought that I should share this information. This is very good to have information if you are working as an architect, if you are working as an IT administrator, if you are having any sort of infrastructure on big IP products. This is good to have information for you guys. Any questions on this, please? All right, I take it as no questions. Right. So if you are keen to have a certification in big IP, then there is a defined certification path. So it starts with 101 exams. It does not offer you any certification, but it is just kind of an entry level. It is kind of a gateway from where you can start your journey to F5 certification. So it further divides into two parts. If you are going to have your future in kind of a solution architect kind of field or technical specialist kind of field, you will have to do a certified administrator certification. That's 201. And there is also a program that is specifically designed for the sales guys, that is 202. And if you are done with your 201, then you can move from the administrator track to the specialist track. So there are different modules to this, like 301, which is a combination of two exams, that 301A, 301B. So the A is more specific to how you are going to deploy the things, and the B is more specific to how you're going to troubleshoot the things. That's specific to BigIP LTM. And similarly, you can choose any of these tracks. You can go to 302 or 303, 304. These are specific to different domains. Like 302 is specific to your BigIP DNS. 303 is for ASM. 304 is for your APM. And after completing one of these certifications, if you want to go into the expert level, then you can choose any of the two domains, two certifications. So 401 is specific to security and 402 is specific to cloud. For more information that's available on their website, you can anytime go and refer to this. All right, now let me spend some time on explaining the TMOS. I'm not sure how many of you are aware of this, but as of now, we have we have reviewed what all kind of platforms BigIP offers, and also we have reviewed what all kind of software modules it offers. Right. So if you noticed it, I never said that this hardware is specific to only this module, this hardware is specific to that module. It does not work like that. If you have a hardware, any hardware, what we have reviewed in our earlier slides, you can choose any of the hardware that, depending on your throughput requirement, depending on how much SSL offloading you want to do, how much programmability you want to achieve, you can choose any hardware and run any of those software modules on top of it. So if I have one hardware, pick any one, I can run LTM on top of it. I can run GTM on this as well. I can run APM, I can run ASM, AFM, SWG, anything on this. So regardless what platform you choose, you have flexibility to run the software on top of it and utilize that as a service. And all these softwares are license based. So you purchase a hardware, or you purchase a VM version, and it is of no use until you purchase the license of that specific software module you want to run on top of it. Right? So the hardware, so the underlying operating system of these hardwares or the VM, that is Linux. So we can consider that Linux platform, that's an underlying platform. On top of it, BigIP has its own operating system, which is known as TMOS, or Traffic Manager Operating Systems. Right? So on that Linux platform, it runs TMOS, and then TMOS supports all the modules which you want to run on top of it. So that's a basic layout of the operating system, how BigIP product offers. So TMOS is something where you run all your modules on it. So that's an overlay. That's kind of an overlay operating system, which allows you to utilize any of the services being offered by BigIP. All right, let's move to other slide. Right, so now we are gradually jumping into the world of load balancing, as our as we have dedicated this session for the LTMs. It is very much required to have an understanding of entire landscape and what are the options available to us if we are talking about a server load balancing. If you know all these things, then it will be easier for you guys to pick and choose the options which is best suited for your environment. Not just your environment, it is the best suited options for your requirement as well. So what I mean to say that if you have an infrastructure, an IT infrastructure, do you really need an F5 device? That's what you can decide. And if you already have an F5 device in your infrastructure, you come across with a requirement of a server load balancing. Which option would be the best suited for that particular requirement? So if you are having the holistic view of the options available to you, it will be easier for you to take a decision on that. Right, so if we talk about the common ways of server load balancing, so as you know that if we are having a web server, if it is a single server, there is a certain limitation in terms of its hardware resources, in terms of its licensing, in terms of number of connections it can take. So there are a lot of limitations to a single server. It could be a web server, it could be any server. It applies to everything. There is a certain limitation to everything. So if there is a situation where I know that the server which I have commissioned for a certain application, that is likely to be exhausted by the number of connections, the number of processing which is being demanded. So we'll have to look around to find out what are our options to increase the resources so that it could take the load, it could handle the load efficiently without giving any any problem to the customer experience. So the customer experience should be intact. So that's the requirement. So how we can do that in a normal scenario, that there are a couple of options. So the first one, we can talk about the server clustering. You must have heard about this. So it is kind of a simple thing that you have multiple servers, kind of the same build of servers. You club them together and make it a cluster. So for an external user, for a user, they would see this cluster being a one big server. You just club all these servers and create one cluster. So the limitation of this, I mean, this is good. This is one of the options. You can combine 2, 3 or more servers into one cluster, and in this way you can increase the resources which can, of course, fulfill the requirement. The requirement. So the server clustering, there are certain limitations attached to the server clustering as well. So when I say limitations, there are limitations that you will have to use the same vendor for all the servers. There may be specific licenses which allows you to create those cluster. They all must be running on a same version, and etc. There can be a lot of other limitations as well. So this is a good idea when you have a very specific requirement for a very specific applications, and you can you can afford purchasing the licenses for a cluster and keeping your infrastructure all in the same place, right? So that's a server clustering. You club more than one servers together, you create a cluster, you offer, you publish the services, and that cluster can, you can share the resources among the servers which are there in the cluster. And so the next one, if I talk about, that's DNS load balancing. So DNS based load balancing is a way where you play with the DNS and you share the traffic among two or more than two servers. So what I mean to say that if you have a kind of a URL and you have three servers, server 1, 2, 3 behind it, and each server is having its own IP addresses. When someone hits that URL, the DNS load balancer can pick one of the IP addresses of these three servers and assign it to user. So user number 1 gets the IP address of server 1. He will create a session. He will only talk to the server number 1. If some other user try to connect to the same URL, the DNS load balancer would say, okay, you are second in the queue. I have already given the IP address of server 1 to someone. Now it's your turn. So it will assign the IP address of second server to that new user, and that new user will now be creating sessions to server number 2, and similarly for server number 3. So what happened in this scenario? In this scenario, you just directed all the traffic to the server one by one. I mean, you can choose the load balancing method as per your requirement. It could be a round robin, it could be least load, or there are other as well. You can choose the load balancing method as per your requirement, and it will just offer the IP address of that server as per the load balancing mechanism you have defined. Right, so user number 1 will get the IP address of server number 1. User number 2, if that's a new user, he will get the IP address of server number 2. And user number 3, if someone comes new, he will get the IP address of server number 3. And then this repeats. So this way, not all the users are going to a single server. We have successfully distributed the load among all these 3 servers. Right, so the next option is available to us, that is traffic load balancing. So when we say traffic load balancing, you can quickly refer it back to our initial slides when we mentioned that LTM is a local traffic manager. So in this kind of load balancer, it gives you a feasibility to create one IP address, and behind that one IP address, you install all your servers. I mean, it could be more than 2 servers. You can suppose you have 4 servers. You bind all those 4 servers behind one single IP address. And this single IP address, which we normally refer to as a virtual IP, is given to the user to access. I mean, of course, nobody uses the IP address to browse it. You can create a normal DNS entry for a URL, for a host name, you want to point to this virtual IP address, right? So in this kind of load balancing, all the traffic, when I say all the traffic, it means the actual traffic, that is forwarded to your local traffic manager. I mean, the traffic load balancing platform. And from that platform, it takes a decision according to its load balancing algorithm, which has been configured. It picks one of those 4 servers, which we initially said that we are binding all these 4 servers behind one virtual IP address. It picks one of them and then forward the traffic to that server. So the next user comes in, it again goes to the load balancer because that's where we have defined our virtual IP address. And it again takes a decision. Now, who is the next in the queue among all those 4 servers? So it could be server number 2 or 3. I mean, that depends on the load balancing mechanism. And then it forwards the traffic to that server. And this is how the traffic load balancing works, right? So now if I go back to the DNS load balancing, the second option what we discussed, there is a thin lining of difference. So when I say DNS load balancer, so let me correlate it. So the DNS load balancer, as we had a quick look in our initial slide, BigIP is offering BigIP DNS, which we usually know as GTM. That product offers DNS load balancing options to you. So there is a difference how DNS load balancer or our GTM and our LTM, which is a traffic load balancing platform, works. So the difference is that when we are doing a DNS based load balancing, the traffic does not travel through your BigIP appliance, because in our scenario, we just provided user with the IP address of one of the servers which we want to forward the traffic towards, right? So the difference is that if you are configuring something on LTM, all the traffic will have to travel through your LTM device. Why it is important to know? It is important to know that because if you are going to build a new setup in your environment, in your infrastructure, you should consider these points, because more the load which is coming on your local traffic manager, the more throughput you would be requiring. So this is good to have information. And in case of GTM only serves your DNS queries. So the traffic, whatever will be hitting to your GTM, that would only be your DNS queries, which are very light in volume. So in that case, the traffic, the actual traffic, the data traffic, the web traffic, that does not travel through your GTM. It just takes care of your DNS queries, right? So any questions at this point?
Yeah, hi.
Hi.
Did we discuss the product features?
Yes, I think we discussed it.
Sorry, actually, I joined late actually.
Yeah, yeah. We discussed it. We discussed it. So no problem. I will be explaining a little bit further in our next slides as well as we progress. So probably you can pick those inputs from there. So to the today's session, in the beginning, as I mentioned, that is to lay a foundation, just to lay an understanding for you guys that if you are working as an architect in your in your organization, or if you're an IT administrator, you should have a holistic view what kind of big IP services you have in market and which are commonly in used, because they all work hand to hand. So there is a high level of possibility that if you are having LTM in your environment, um, there is a big possibility that that organization will also be having GTM services being deployed somewhere in the environment as well. Um, they can run independently, of course, they can, depending on the requirement, but most of the medium to higher scale organization, they use the mix of it. Right, so that's why I'm explaining the GTM part as well and LTM. Then we will gradually move to our core, the core topic, that's LTM. So yeah, just stay with us. We'll certainly touch base with all the things. All right. So why LTM? Why LTM? All right. So LTM, as I mentioned, it offers you the 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 traffic management. So when I say traffic management, um, as I explained in the previous slide, all the traffic will have to go through this appliance, and there will be a lot many things happening on this device apart from a load balancing thing. So since your traffic is passing through these appliances, you have a capability to play with that traffic and use it according to your requirement. So let me go back to the example what we discussed in our previous slide, that we create a virtual IP and then we bind number of servers behind that virtual IP address. Right? But when you start working on LTM, we indeed create a virtual IP address, but that is not known as a virtual IP address. That is not called as a virtual IP address. We rather call it as a virtual server. So name itself explains everything. So if I just needed a platform which could only provide you the feasibility of creating a virtual IP address and binding number of servers behind that virtual IP address, there could be other applications or other protocols maybe maybe discovered. But it is not just binding all the servers behind a single virtual IP address. It is lot more than that. It is lot more than that. It is as good as you are deploying a complete server on your LTM box. So that is the reason why BigIP LTM calls their virtual IP instance as a virtual server. If you talk to your colleagues in day-to-day scenarios, they may come to you saying that, can you please check that VIP for me? I mean, this is a very commonly used term. That's, can you please check that VIP? My VIP is not working. What is VIP actually? VIP, it's not VIP. It's not VIP. It's virtual server, because it is not just offering you the server load balancing based on a binding of servers behind single IP. There's a lot many other things which you can achieve. So what you can achieve from these BigIP LTM devices. So it works in a full proxy mode. That's the feature which makes it stand apart from not many other load balancers. What I mean by full proxy mode, I will explain it in my coming slide. But before I move to those slides, I just wanted to set your understanding what is proxy and I mean why we are using this term. So the proxy in a normal term, even if in the IT term, is a device which talks to a network on someone else's behalf, right? The proxy means that you have a device which talks to the resources on your behalf. You don't need to go out and talk to that resource directly. There's an appliance who will do all the things for you. Just like we have kids at home. If any kid need something, they will only request it to their parents. I need this thing. And the parent will go to market and bring that for the kid, right? So this is because the kids are vulnerable. They are, they are considered delicate. We want to safeguard them. So the parent is working as a proxy. They are going to the market and they are bringing the stuff on behalf of the kid and handing it over to the kid, right? So kids are safe at their home. They don't need to go and jump the traffic lights on the streets to get the things what they want. So this is what proxy means. So there are two kinds of proxy which are usually being used in our IT environment. One is known as a forward proxy and one is known as a reverse proxy. Some of you might have listened to these terms in the past, but I can little bit explain what these are. I mean, why I'm doing this, because it will help you understand where you can deploy your BigIP LTM device. As I mentioned, that it is more than a load balancer. There are other things. We will gradually, we will gradually combine the bit and pieces what we are discussing together as we move forward. So coming back to proxies, we have a forward proxy which you normally use in your office environment. If someone wants to access the internet, you need a proxy server which will intercept your traffic, see what you are going to serve over the internet. And if you're a legitimate user, if your request is legitimate, then this proxy server will talk to the internet on your behalf. Again, it's coming back to the term on your behalf. That user need not to go out to the internet directly. There is a proxy server dedicated for this. You talk to the proxy server will talk to internet on your behalf. And there is a term called reverse proxy. It's quite, it's exactly the opposite of what forward proxy does. So the forward proxy is your outbound connection to an unsecured network. Unsecured network means some users trying to access the internet that is considered as the most unsecured network. You use the forward proxy. In our first slide, where we were mentioning the different, where we were discussing the different software modules BigIP offers, so there was a module called Secure Gateway. Sorry, it was I think Secure Web Proxy solution, which is being offered by BigIP. So that offers you the forward proxy features. Now let's
one question.
Yeah.
Can we use LTM as a forward as well as a backward reverse proxy at the same time?
Right. So as a forward proxy, no. As a forward proxy, no. But as a reverse proxy, to some extent, yes. I will explain you. So no, you cannot use it as a forward proxy. You need a certain, as we mentioned in our initial slide. So it's a secure web gateway. That's a software module it offers. If you have a hardware where you are, or if you are having a virtual edition where you are already running LTM or GTM, you can purchase the license of secure web gateway and you can install it on top of it. Then of course you can use it as a forward proxy. It's a different product. But if we stick to LTM, we can utilize LTM as a reverse proxy with no additional modules.
So
when
basically,
yeah.
reverse proxy means from outside the user, from outside to DMZ.
Yeah, from outside to DMZ. Yeah. So as I said, we can to some extent utilize LTM as a reverse proxy. I will explain you. I'll explain you in what scenarios we can use this LTM as a reverse proxy. So just stay with me. We'll certainly come to that point, and that will make the things a lot clear.
Okay.
Right. So reverse proxy, as you correctly mentioned, that reverse proxy is kind of an opposite thing what forward proxy does. Is the incoming traffic from an unsecured network to your more secured network. Right. So now I can go back to my previous discussion, that there are two kinds of applications which you can expose to the public network. So the first kind of application is the application which is openly available to public, which is openly available to normal public. You go to bbc.co.uk, you can surf anything. You need not to log in. You don't need to prove your authenticity. As long as you have internet access, you go and browse it. Right? That's one kind of application. The second classification of application is, which is of course published to the internet, but that is intended for a specific set of users. Like you have your company's intranet, or you have Citrix. Like you launch mycitrix.something.com, and then you provide your credentials, etc. So the both kind of applications are published, but at first kind, I mean, for first kind of application, you don't need to provide any authentication. You just simply go and browse that. On second kind of application, you will have to prove your authenticity, that you belong to that organization, you are authorized to use that application. Right? So if you are just running LTM, if it is just a plain LTM, you can utilize this for the application type 1, where you don't need authentication. Does that make it clear?
Yes. Okay.
Right. So what I mean to say, I mean, if you have a little bit of understanding about this feature, this reverse proxy feature, you can of course review your environment. You can see what all kind of applications you are using. If your company is investing to some DMZ gateway which is just there to provide you the reverse proxy solution and not doing any sort of authentication, etc., and you also at the same time have LTM, at that given time you can move that LTM, I'm sorry, you can move that application gateway which is specifically deployed there in your environment for the reverse proxy solution for a specific application. You can move this functionality from that server to your LTM, as long as authentication is not your requirement, right? You can save some money on that part as well for your organization. But if it's just a plain application, you don't need any authentication, and there is a server sitting in your DMZ closet, which is just there to provide you the reverse proxy. You can simply say that we can save the money, we can just decommission this one and move the functionality from this server to my LTM. And this is a real life situations. People usually do that. If you have a clear understanding of how an application works, you can utilize this box in an amazing way. Right, so now we cannot left the second category of applications behind. So the second category is where you need certain authentication with a reverse proxy solution as well, right? So in that scenario, BigIP offers you APM, Access Policy Manager. So as the name suggests, again, Access Policy Manager is there to handle your access policies related requirement. You can do your MFA on that. You can just you can do an AD authentication with that. I mean, you can do SSO with that, single sign-on, etc. So there are a lot many other things you can do with APM, Access Policy Manager. So for second category of application, what you can do for second category of application where you require authentication, you need LTM, and on top of that, you would require an APM as well. Right. So again, I'll come back a little bit more for a full proxy thing which we discussed here. We'll see how the connections is built, why we call it a full proxy thing. But for now, let's just move and see the other benefits of LTMs and why we should choose LTM in the first place. So the next interesting thing is programmability. So again, I'm coming to the same point. It is not just about having an IP address and binding more than 2 servers behind that IP address. It's not that. So why I'm saying it again? That because these LTM boxes, if you have, as I mentioned earlier, all your traffic passes through this box. When it passes through your box, it gives you an ability and flexibility to program that traffic according to your need. So there are a lot many things which you can do. There are there's a term called I rule. You can create a program, you can create a script where you can mention what you want to do with that traffic. For an example, I want my users, whosoever is trying to hit this URL on HTTP, I want that URL, I want that traffic to be auto converted to HTTPS, not traffic actually, that request to be auto converted to HTTPS, because I am hosting that traffic, I'm hosting that application on HTTPS. I'm not hosting it on HTTP, but sometimes user tends to write only the domain name. Suppose if I type bbc.com and I hit it, by default it may pick HTTP. But when this traffic hits me on the LTM, I can define an I rule that if by default, if by mistake users type it HTTP on its browser, I will change that URL to HTTPS and then accept the traffic on HTTPS because I am hosting it on HTTPS. I mean, this is just one very basic example. There are a lot many other things which you can do on this. Another example of that, I want to have a URL. It's just suppose bbc.com. I'm having certain URIs behind it, and I want to say that if someone types bbc.com.co.uk suppose /finance, then there is a different set of servers where this request should be going towards. And if it mentions HR/HR, then there's a different set of servers this request should be served on. So this is just few examples just to give you a little bit of idea what you can achieve on LTM. Right, so you have flexibility of using the script, create an I rule, place it there, and you achieve what you want to achieve on that traffic, because this traffic is eventually passing through your LTM boxes and you have visibility to it. Right, so next one is blazing fast SSL. As I mentioned in my initial slides, that all the hardware platforms, they all come with their dedicated SSL hardware modules within the actual hardware. There's a dedicated memory for that, dedicated provision for that. So that makes that SSL offloading very fast. Now we can explain it like if you are just running 3 servers, and if I ask you to offload the SSL on all these 3 servers, the resources of all these 3 servers will partially be occupied dealing with the SSL encryption and decryption and all that. Since these LTM devices come with a separate provision for SSL offloading, you can offload this task from the server to these LTM devices. So let LTM handle with your SSL offloading, and let all the servers sitting behind these load balancer do what they are meant to do, right? So in this way, you get a very good response on SSL offloading.
Deepak, sorry to disturb you.
Yeah.
Can you please explain me a bit about SSL offloading?
Okay, right, no problem. So if you know SSL, so the SSL is the way you securely communicate with any application, right? So when in the browser you type HTTPS, it creates a secure socket layer, in where your traffic is encrypted, and that talks to your application. I mean, you talk to the application directly in an encrypted format, so nobody can intercept that traffic. So that is a secure way of accessing your web resources or applications. So now suppose if I have a server, and I want my application which I'm publishing, which I'm hosting on this server, to be secure, I'll have to install the SSL certificate on this server. So what happens when a user initiates a connection to this server? There will be a SSL handshake happening between the actual user who is accessing this application, and the server who is hosting that application. So when I'm saying server, it is the actual server. It's not, at this moment, I'm not talking about LTM. So the server is user is directly talking to this server. The server resource.
Deepak, sorry. So the traffic will reach first to the LTM virtual server IP address, right?
Yeah. So I'm just talking about a scenario where you do not have LTM, right? Then we will shift towards LTM to see what difference it makes. So probably I can draw something here. Let me see if I can. Right. So so now suppose that's your server, and there are 3 of them. Sorry about my drawing. So there are 3 servers, and suppose we have picked DNS load balancing, where the user is directly communicating with these servers. So that's my user. If he wants to communicate directly with this server, there has to be an SSL certificate on this, and on this user's browser, this will communicate with this SSL certificate, and the resources of this server that will be consumed doing this thing, right? As I mentioned initially, that just in case you are using the DNS load balancing, the user directly talks with the server. User can directly talk, but still do some sort of load balancing, either to this, either to this. We will explain it. Of course, we will do that, just in case if it is not clear. But just consider it as a scenario where we do not have an LTM in between. We have to install the SSL certificate on our actual server, which is hosting the application. So when you have engaged your actual server to negotiate the SSL with the user, there are certain resources will be consumed on those server to deliver that task, to do a handshake, to do everything. And So when you have LTM in between, so suppose in this case, I don't want my users to talk directly to this servers. I have an LTM in between here. Again, sorry about my drawing. And instead of this user is talking to different servers, now he can talk to one single web. And I choose that I don't want to do an SSL offloading on these servers. I will shift this SSL offloading from the server to this LTM. Now this will do my SSL offloading, and I can offload the task of SSL handshake from the server to the LTM. So now the user will do the handshake directly with the LTM. So all the SSL requirement will be taken care by your LTM. So what you are eventually getting, so you are eventually offloading some processing task from your actual server, and you are handing it over to your LTM. It means that your servers can now work efficiently. I mean, they would still be working efficiently, but of course it will ease some load on those server. Right? Does that make sense? So it is just like, it's just like, you know, outsourcing things. You must have heard in your normal life that there is something which you have been doing on your own. Now you have appointed someone who can do that specific task on your behalf. So earlier you were doing SSL offloading on all those servers sitting behind, on all the servers which were there supporting your infrastructure. So all the servers were engaged doing that SSL handshake and encryption and decryption thing. Now you have handed over this task, as you now have LTM, handed over this task to LTM. Now the server need not to do any SSL transactions. That will be taken care by LTM, because now LTM is front facing to the customer, to the user. User will directly negotiate SSL with the LTM, and then LTM will forward this request directly to that server. So this is
That
a
will
very
be unencrypted, you mean?
Yeah, it can also be encrypted as well. I mean, we can choose that, because as I mentioned, there are a lot of options available in LTM. So in some scenarios, you may come across with some scenarios in your practical life that your servers and your LTM, they both are sitting in a secured environment. When I say secured environment, they are probably sitting in the same LAN, or maybe sitting in the same secured corporate network, your corporate network. So some users, some IT administrators say that I don't mind that my LTM talks to the server as an HTTP. I don't mind that, because that's my secured network. It's just like I am sitting in my home and talking to my parent. We both are in the same home. We can talk. We can talk clearly. We don't need any encryption or coded language, because we all are part of the same secure network. On the other hand, if you because they are the two resources, LTM and your server, they all are part of the same network. All are the part of same home. Like, I mean, it is somewhere can be acceptable that they can, yes, of course, talk to clear text. There's no problem in that. Just like I talk to my father, I talk to my mother. We all belong to the same home. But if someone knocks at my door my doors actually opens to the outer world, which is an unsecured network. I would not let my child go and open that door. I'll dedicate someone to do that for me. I'll not allow everyone to go out and see who is knocking at door. Right? So I have dedicated this task similarly to an LTM who is now doing this thing, this SSL offloading thing on behalf of my environment. And if your environment does not allow you to do that clear text communication between LTM and the actual server, yes, there are options as well. There are options as well. You can then do the both things. You can have SSL offloading on your servers as well. You can at the same time have an SSL certificate, have an SSL offloading on your LTM as well. But why do we need at these two places? We need it because we need to engineer the traffic. If I want the user, which is if I want the user traffic to pass through the LTM and go directly and negotiate directly to the server, I can do that. I can, of course, do that. But in that case, if you ask me, because in this case, if the user is creating a direct session with the actual server, even if we have LTM in between, and we allow that user to create SSL connection directly with the server, and we are not offloading it on the LTM, we can run this traffic perfectly fine. We can run it. But if you come up and say that I want you to do some engineering on this traffic, I want you to implement some redirection of this traffic, you cannot do that in that case. Why? Because if you're just offloading your SSL certificate on your server and you're not offloading it on your LTM, the traffic is, of course, yes, it is passing through your LTM, but it is all encrypted. So if it is encrypted, that means you do not have any visibility what is passing through your load balancer. So if you cannot see what is passing through your load balancer, you cannot create any condition, you cannot create any I rule, because you don't know what it is. It's just a gibberish which is passing through your load balancer. So in a nutshell, you can choose multiple ways of implementing. You can choose one of the multiple ways of implementing SSL in your environment. So the first option, if I say that user communicates securely only with the LTM, and LTM talks to the real servers unencrypted. The second option, you can have your user to communicate with server directly, but that traffic will certainly go through the LTM, but the SSL negotiation will only happen between your user and the server. And the third option is where you are having SSL offloading on both sides, like your actual server as well as your LTM. Right? So there are three possible solutions to this, which you can implement as per your requirement. So your requirement can vary depending on your infrastructure. Some of them may be specific about security concern. Then yes, of course, you can use it at both sides, on the server, on the LTM. Some of them, some of the requirements may be specific about the server load. And you can, of course, choose not to have SSL offloading on the server. Rather, you can offload it to the load balancer. And some requirement, you just don't want to kill your LTM resources to do all these things, SSL offloading, other thing. You can allow your user traffic directly negotiate SSL with the server. So there are three possible conditions what we can have. Right? Any questions? Right. Okay. So now let's talk about the TCP optimization and performance optimization. So performance optimization is something, as I just briefly gave you an example of SSL offloading. So performance optimization means that, as I mentioned earlier, this is not just a web, it is a virtual server. You can utilize LTM to deliver some of the functionality of an actual server, which means you can choose to offload some of the heavy lifting tasks of your actual server to LTM. So LTM will do that thing for you. Your server will only serve what it is meant to serve, right? So just like for an example, we just talked about SSL. We can choose to offload the SSL from the server to LTM. Of course, that will reduce some load on the servers. Similarly, if I want some crazy redirections happening on my URL, so just for an example, I give you a quick example that if I have a website, netminion.com, right? If I'm accessing it from UK, it will go to netminion.com. If I'm accessing it from India, it will be maybe. I mean, I'm just giving you the scenario. It's not how I'm telling you, but just for sake of understanding, suppose I'm accessing it from India. I want that URL to be converted into netminion.co.in. If I'm accessing it from India, if I'm accessing from UK, it should be netminion.co.uk. Just for sake of example, right? So you can achieve this functionality. You can create a script on your load balancer, and you can just ask your load balancer to do all these things on the behalf of the server. You can, of course, do all these things on the server as well, but you just offloaded this task to your load balancer. So in this way, you can utilize the resources on LTM to handle some of the heavy lifting loads, for on behalf of the actual server, which definitely improves the performance. Right. So the next one is TCP optimization. I think that's where we'll stop today, I guess, and we'll possibly explore other things tomorrow. Right. So let me explain you TCP optimization. So the TCP optimization, as I mentioned, it works in a full proxy mode. So the full proxy mode, as I mentioned earlier, that the proxy is something which talks to some resources on your behalf. The similar way your LTM works. So suppose, so here is, right. So take this example. So here we are having these users. So this is the user. If this wants to communicate to this application, which is hosted behind this virtual IP address. Probably I can name it anything, abc.com. So this user initiates a connection to this virtual server, which is configured on this LTM, right? And now what happens in this case? In this case, the user, there will be two set of TCP connections which will be created for this communication. So the one set of communication that will happen between the user and the LTM, and the second set of communication which will happen between the LTM and the actual server. It could be any of these three servers, depending on the load balancing algorithm what we have selected, right? So when I say two set of connections, so there will be two set of TCP/IP handshake happening at the background. So user will be negotiating its TCP session with LTM, and LTM, after taking a decision which server it has to forward that traffic towards, that LTM will initiate a connection with that server. So that's the first one, that's a second one. Now this actual user, will never get to know which is the server is serving his request. He is just talking to this LTM. He can only see the virtual server configured on this LTM. So it fulfills our definition of a proxy, what we discussed. Like, we are having our LTM box in between, which will talk to the actual server on behalf of the user. User is not allowed to talk to the server directly, right? So you must be having a little bit of understanding of how three-way handshake happens in TCP. It's kind of the same, as I mentioned, that two separate strings of TCP sessions. So user will send a SYN packet to LTM. LTM will respond it back with SYN ACK, and then a response goes back with SYN. And similarly, the second TCP handshake happens between the LTM and the server, which LTM picks as per its load balancing algorithm. Right. So now I was detailing about TCP optimization. So the TCP optimization, what I mean to say is, probably I can fit it in this example. Now, if we know that we are having two set of TCP communications happening, we can manipulate these TCP connections according to our need. What I mean to say by that. So suppose this could be this user can be coming in, this user can be coming into your LTM using some internet, maybe MPLS, right? So the connection performance of this link may not be as good as this side of link, right? Because the user, suppose he's coming from the internet, is using that internet link which is tied down to a specific bandwidth. You're just coming over the internet. There may be some latencies over the path. The communication between the user and the LTM may not be as good as it is between this LTM and the actual server, because they are probably sitting in the same corporate network. So you get a wired speed, just connected hardwired to the servers, or you are connected hardwired to the LTMs as well. So of course there is a difference. So LTM offers you the different kind of VIPs which you can create, the different kind of TCP profile you can create to manage these two connections individually, these two kind of connections individually, right? So for an example, if I know that this side of link is slow, it's internet, we can we can compress the traffic while we are sending it back to the users. And this side of network does not require any compression because it is all hardwired, right? Does that explain everything? That why it is said that it offers TCP optimization? Because now that you have two layers of TCP connections, F5 offers you flexibility to play with these two connections, these two kind of connections separately. At one side, you can enable compression. The traffic, whatever is responded back to the user, that will be forwarded as in a compressed format, so that you could better utilize your links, whatever is available there. You may also choose the compression on the other side as well, but that's not usually the case. But of course, you have tools in your hand just in case this LTM is, in a hypothetical scenario, this LTM is sitting in a data center and your servers are sitting in some other data center. There is a heavy traffic going on between the links in these two data centers. You may again choose compression, so that you could optimize traffic. All right, so does that make sense to everyone? Right. Okay, so I think we should stop today at this point. We can continue this session tomorrow. We will we'll try to create a lab tomorrow for our LTM practical stuff. And I'll also try to explain a few of the slides which are mentioned, which are still pending. I'll try to explain other components as well. So I think we are good to wind it up at this point.
Thank you, Deepak. Thank you for such a wonderful session.